Right, welcome back again. We're going to focus on the 7 states of OSPF adjacency. We're going to see those 7 states by debugging. In the previous class, we debugged IP OSPF packet, but this time I'm going to do events. Debug IP OSPF adjacency. Events will show you all the OSPF events. Adjacency will show you only the adjacency related events. So what I'm going to do, I'm going to shut down. First, I would like to shut down this interface serial/0. The interface down. Show run interface serial/0. We don't even run OSPF. What happened? Show IP OSPF process. Okay, let's first of all enable OSPF. What about this router? Show IP OSPF interface brief. No. Okay, no protocols. I didn't save the previous class configuration. It is okay, we have at least IP address. Show IP route. It shows only loopback because you remember the serial link I shut down. So that network 1012 won't come. Line protocol should be up for routing table to show the route. The physical interface network. Okay, OSPF. Router OSPF 1. Network 2.2.2.2. Network. I'm masking it completely. Do show, sorry, show IP OSPF interface brief. You can see two interfaces running OSPF. Next, we are going to go to the next router. Before that, I would like to enable debug IP OSPF adjacency. ADJ is the command, and you see the state is down. It's in down state now. See the serial 4/0. The state is down. It's in down state. Debug IP OSPF. Interface loopback 0. IP OSPF 1 area 0. Interface serial 4/0, which is down. I'm bringing it up now. After enabling OSPF, I'm bringing it up. Let's wait for the logs. In this log, you will be able to see the states, adjacency state. If you go up, You see two-way state. In some operating system, you can even see init state. You can see two-way state on both sides, meaning they know each other very well. Now, if they want to share the DBD, they need to decide who is master and who is slave. That decision making is happening, you see down there. Negotiation done. Before that, you see, we are not slaves. Who is saying that? Router 2 is saying, we are master. The reason is router 2 has got the bigger router ID. So this is not DRBDR. DRBDR election also happens in this place. But this is serial link, no DRBDR is needed. So temporarily there is a master slave, so that master can start distributing the DBD, followed by slave. After that, there is no more master, no more slave. Just for deciding who will start the DBD. This master-slave relationship won't continue. You see the other router, router 1. Router 1's router ID is 1.1.1.1, so router 1 accepts we are slave. So here this says I am the master. I'll send the DBD. I'll send the DBD followed by R1. And then they will have some queries, that is what called as link state request. This is the place where we call it as exchange state. Xstart state, after two-way is Xstart state. You see Xstart state, where they conclude the master slave thing, and then exchange. Exchange place, the place where link state request is made on both sides, and link state updates are sent. After the exchange is done, it goes to load on full state. Loading state is the place where the sending of LSR and LSU. Exchange place is the place where DBD is exchanged. DBD exchange state. Loading state is what? LSR, LSU. Once there is fully loaded, fully synchronized, when there is no more exchange, there is no more queries, it reaches full state. This is what called as adjacency, full adjacency. We'll have 10, 25, 34.0/16. Sorry, 24. So router 5F00 will have 10.25.34.5. IP OSPF 1 area 0. One more thing, what I'm doing is I'm going to set priority so that router 5 will be a DR. If you don't set priority, they're going to compare the router ID. Then also router 5 will become a DR. Loopback interface IP address will be the router ID of each router. But I would like to manually give IP OSPF priority 100 and write to memory. That's all. This is what will go on router 5. Okay. Now router 4's configuration. Router 4 I want it to be BDR, so I'm giving 50. The default is 1. We all know on Ethernet, fast Ethernet, all Ethernet it is 1. This is going to be 4 here. Now for router 3. For router 3, I don't want to set any priority. I want to show you the default on router 3. Okay. Now router 2 has got another newly added interface where we need to run OSPF. So I'll go straight to router 2 and say interface F00 IP space address 10.25.34.2 IP OSPF. Okay. Now I'm expecting neighbor, 3 neighbor, OSPF neighbor. Okay, router 4, router 5, router 3. Something is wrong with router 3. Let's go to router 3. Nothing is wrong with router 3. Why didn't come? Show IP OSPF neighbor. Okay, router 3 is in 2 state. Okay, that's good. Look carefully here. Router 3 and router 2. They will not go beyond this two-way state because they both are DR others. See, for router 2, router 3 is what? Is it a DR? No. BDR? No. It's DR other. DR other means I know you, you know me. That's it. No more discussion. No sharing of TBD, nothing. But router 2 has got full adjacency with 5555 because router 5 is a DR. And router 2 has got a full adjacency, meaning it is sharing everything with BDR also. Now let's go to router 5 and see. Show IP OSPF neighbor. You can see that router 5 has got full adjacency with everyone. Let's go to router 3 and see. Router 3 says I got only two-way state with router 2. That's right. Between 2 and 3, there is only two-way state. Down any two-way. That's it. They don't share anything. Now I would like to show you the default priority on router 3. You already see here, but this is neighbor's priority. Let's go and see here. Show IP. This is the command OSPF interface F00. It shows the timer here. Priority. The previous class I was showing that there is no priority for serial interface because the priority is 0. It didn't show there. And one more thing, you see the network type. On the Ethernet links, the network type is not point-to-point. It is broadcast. I showed you on router 1, it is point-to-point. Even in router 2 serial 4/0, you can see that. Show IP OSPF interface brief. You can see that point-to-point. And the default priority, if you want to see, you need to say neighbor, or you can go under the interface. Show IP OSPF interface serial 4/0. There won't be any priority. And it is point-to-point. Network type is point-to-point. On a serial link, network type is point-to-point, where there is no DR-BDR election. But on the other side of the router 2, fast Ethernet 00 shows that I have a DR, which is 5.5.5.5. I have a BDR, which is 4.4.4.4. The network type is broadcast. The priority is 1. I'm talking to the designated router using this address. I'm talking to the backup designated address using this address. Who is saying this? Router 2 is saying these things. That's right. Anyone want to see anything here? I can show you if you ask. Do you understand what you are seeing? Anyone want to see something? I can show. Based on what you have learned, if something you want to see, then ask. This is a familiar chapter for you because we finished our configuring OSPF. We did OSPF configuration in two different approaches. One, this approach which you see here, going under router OSPF in the global configuration mode and saying network, wildcard mask, and then the area ID. We also did this method under the interface. You do either this or that. On a router, you can have both mixed. For one interface, you can do the The custom one, the first two-line one. For other interface network, you can go under the interface, like what you see in the third one, optional method. But I am always comfortable with this optional method, the third one. The reason is I no need to worry about wildcard mask. You can follow anyone you like. You see here we see the custom method, everything under router OSPF. And what are the other things you learn here? The process ID can be different. This is just a process ID. It is locally significant number. And here we see on router B, they have mixed both the methods. On the serial link, OSPF is configured. For the Ethernet link, it is configured under router OSPF. It's okay, you can mix. And because there are two areas, this router B will have different area configured. That makes this router to be ABR. I repeat, if a router has got a membership with an area and also a backbone area, router B has got membership with area 1, also with backbone area 0. We call such routers as ABR. Never call this router as ABR. If this is router, if this is area 2, this is area 1. No, this will not be a border router. This cannot be a border router. Why? Area 1 routes won't go first of all. It won't go. Advertisement LSAs will not pass through because from non-backbone area, if an LSA need to go, it will go only to area 0. Non-backbone area mean what? Other than area 0. All other area routers, all other area LSAs or non-backbone LSAs. Non-backbone LSA will only go to backbone. It won't go to another non-backbone. OSPF won't allow that. Area 2, area 1. In between I have router B. Will that be a border? No way. It is like Mount Himalaya. Is Mount Himalaya border? Can you cross that border? Maybe today, yes, people do that because they got some high-tech vehicles. But earlier it was not possible. You cannot cross Himalaya, you will die if you try crossing Himalaya. Today people go to the tip of Kanchenjunga and put on flags. About the router ID, it's a well-known story for you, but I would like to just repeat once for the presentation's sake. You see, every router needs to have a unique ID. If user gives a name as ID, there are chances that by mistake, two routers will have same name and it will create conflict. So what OSPF designers, the developers done is, they made OSPF to pick an IPS from the interface as a router ID. Simple. Whether you run OSPF on that interface or not, if it is qualified to be a router ID, it will be picked as a router ID. See, this may be a silly question, but it is not silly. It's important. Many people did not answer even this silly question, so it is important. What is the question? I'm not running OSPF on Lubeck interface. I'm not running OSPF on Lubeck interface. Will OSPF pick that Lubeck interface address as a router ID? Answer is yes, it will. It is just a name of that OSPF process running on the router. Need not to be advertised. See, in our lab, let's go back to the lab. I'm running OSPF on Lubeck 5. That's true. You can see that. Show IP OSPF interface brief. I'm running it on Lubeck 5, Lubeck 0. No IP OSPF 1 area 0. I removed it. You see, there is no OSPF, but still it's a router ID. Show IP protocol. Show IP protocol. It is still a router ID. Even though this address is not pingable, you cannot ping now. Even though it is not pingable, it will be shown under neighbor table. Show IP OSPF neighbor. You see, it's not pingable. See, this is pingable because we are running OSPF on Lubeck 0 of router 4. But 555 is not pingable because I just removed OSPF from there. It's not mandate. Router IDs are simply ID. It's simply a name. To identify the OSPF running router, it's simply a name. Next. If you see the database, show IP OSPF database, you will have that as an advertising router. 555 is one of the advertising router. You see, who is advertising this network, this particular IP, router 5? This is the F00 interface IP address of router 5. Though I am not able to ping, I still have it as an advertising router because you don't need this one. This is just a name to know who is giving. This is what matters. This is the leak ID. Now, what about this one? This I will not be able to ping because it's not advertised. This is just link ID. Router 5 is saying I have one more link like this, but it is not advertised, so you will not find in the routing table. Show IP route 5.5.5.5. You don't see that, but 4444 you will find it. 4444 is coming from router 4, whose router ID is this. Okay, so the router ID is simply an ID. The designer has made OSPF to dynamically take an interface IP address, because in the real world we don't give same IP address to two different routers interface. So when we don't give OSPF a router ID manually, it is going to pick the router ID from the loopback interface. When you have more than one loopback interface, which one it will take? The big IP address, the big IP address from the loopback interface. For example, loopback 0, A.A.A.8, loopback 20, loopback what? 20. That's the interface name. 2.2.2.2. Which one will be the router ID? Loopback 20's IP address or loopback 0's IP address? Anyone answer? Exactly. It will only focus on the IP. Don't focus on this interface IDs. No. So the biggest IP address from the loopback interface. If you don't have loopback interface, the highest IP address from the active physical interface. Very important. The interface need to be active when you enable OSPF. If the interface is not active, if the interface is in a shutdown state, it won't pick that IP. Loopback interfaces are up automatically, so no problem. But physical interface, when the OSPF is enabled by you, the interface status is important. It is very important. After OSPF is configured, if you go and enable the interface by typing no shutdown, it won't become router ready because it has already picked some other IP address from some other active interface. If you see my notepad, I configured loopback interface first. You know why? Because if I put this one down here, if I put like this, what happens is it will take this as the router ID. Why? When you enable OSPF, the only interface that was active is this. When you put this command, this is not there. Though it is few millisecond difference, it matters. So I always configure loopback interface first. Not only for OSPF, even for BGP, MPLS, or any protocol which uses router ID, which picks router ID dynamically, you should remember to configure loopback interface first. Now let's say you got fast Ethernet 00 with 192.168. Okay, 168.0.1, and this has become the router ID. This has already become what? Router ID. Now I would like to configure a router ID manually. What is the procedure? This is already a router ID. But for some reason you would like to configure on this router 11, 11, 11, 11 as the router ID. What is the process? Process is this. You can use this command and configure it, after which you need to restart the router or reset the OSPF process. This is the command. Where it is in the next page. In the next page. Yeah, this is the command. You reload the OSPF process. Either you reload router manually or reload OSPF manually. The election, the OSPF with the old ID should get killed for the new ID to come. And that's how we do now when you go, for example, if you're renewing a agreement, you will first kill the old agreement, tear it into pieces and burn it, put the new agreement so that there won't be a conflict later. Same way. It's not like a passport office, but now they have changed. Earlier, they give like for 5 years passport. After 5 years, you need to renew. Second time, they will give 10 years. So when you take the second, after 5 years, you go renew the passport. Fine. After renewing, you got the new passport. You go to some country with a new passport now. Oh, olden days, what they used to do, immigration office, they will say, bring the old passport also. Where will I go? In another 2 hours, flight is going to take off. How will I go and bring the old passport? That nonsense rule was there. It was there early days. But I did not face that. One of my friends faced it. So I was very clear when I go to foreign country with a new passport, I also carry my old passports, two old passports. I staple it, all three passports together because I renew 2 times. Third time, I got new passport, three passports. But OSPF is not like that. You should first drop the old identity in order to acquire the new identity. Kill it. Is the recording? Okay. On router 5, the router ID is 5.5. How do I know? Go to router 2 and check. Show IP OSPF neighbor. Who is your neighbor? Okay, it says there is one neighbor called 555. Now I'm going to change the router ID of router 5. Router OSPF 1 router ID 5555. See, to give an address as a router ID, it need not to be there on any interface. This need not to be there on any interface. Router ID 555555. Done. Now, will this 55 be used? Let's see. Show IP OSPF. Hello OSPF. I'm saying hello OSPF. It says yes, I am 555. What do you want? 555. I thought I'm talking to 5555. No. I also told you that you should clear the process. You didn't clear it? Yeah, I didn't clear it. Then he will be only talking to 5555. So not only in this command you see this, you will also see that in a type show IP protocol. When here it is not updated, though you have configured, you see, I'll show you one more time. Show run section router OSPF. See, you have clearly configured saying thou shall be called as 55.55.55.55 from now on. Okay, but what to do? It is not in the Gazette. It is not taken to the Gazette office to change my name. My father and mother decided to have 55, 55, 55, 55 as a name. But an early name they gave me 5555. They did not go to the Gazette office to change it. Okay, let's go to the Gazette office. Clear. That's what they will do first thing. Clear IP OSPF process. Reset all OSPF process. Yes, sir. But this you don't do in the production because it will boom, sound will come. All the routers will reprocess. Not only this router, this is a DR, it is going to impact every router. Now go to router 2 and check. Router 2 has got two guys now. One is 55, the newborn guy. Only you and me know it's the same guy. But OSPF is still maintaining this, thinking that this is the same, this is another guy. And you see the timer here, and this will go 0. 4. 1. Gone. Now it is gone. 555 is gone. So we have to clear. And after that has gone, only this has come what? Full state. Now you see who has become DR? Router 4 has become DR. You know why? When the old DR die, the backup DR will become DR. And when a new DR comes, whatever the priority it may have, even though it has got the biggest priority, because already this DR is there. You see, 444 is DR. When 55 was a two-way, it has to go through that 7 stages. By the time this is already declared as a DR, so this will continue to be a BDR. Actually, the re-election happened, and this guy is a winner because the other guys are having priority 1. This will not participate in BDR election. This is already a DR. It won't participate in election. Election was between this and this. And this says, because I have the bigger out ready, I'll be the BDR. Okay. So what do we call this as? OSPF DR is not elected. It is promoted. DR is not elected. A BDR only will be promoted as a DR. Even in the first time, the biggest router ID router will say, I'm a BDR. And then it will promote itself as DR. So there is no direct election for DR. And this process, when there is a DR, even though the DR has got the low priority, when we bring a new router with a high priority, it cannot become a DR. What do we call it as? Non-preemptive. OSPF DR BDR posting is non-preemptive. Non-preemptive means cannot be taken off in the middle. Once the election is over, need to wait for another 5 years. Need to wait till the OSPF process gets restarted. It is non-preemptive. Someone in the middle cannot come and say, hey, I got the high priority, you get out from here. Not possible. That is not possible here in OSPF. OSPF is non-preemptive. OSPF is non-preemptive. So Router ID is just a 32-bit value. It need not to be an IP address on any interface on any router. All right. So this command I showed you, there are a few other commands. Show IP protocol. We saw that. Show IP route OSPF if you want to see only the OSPF routes. If you have many OSPF on the same router, you can use the process ID. Show IP OSPF interface command I have shown you. I used to put brief so that it won't be too detailed. Show IP OSPF, show IP OSPF neighbor command we have seen. All right, these are all the outputs. Right. So this chapter was only, about configuration and verification. All right, we'll do again another lab with few more concepts after we learn. We'll do another lab, big lab. We'll stop here. Any question?